Let's practice solving and graphing some one-step inequalities together. Now, real quick before we get started, if you'd like to download a free copy of this blank PDF or look at the annotated answer key PDF, you can find a link to that below. And to get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. Now for each of these practice problems, we're going to go ahead and first solve the inequality, so isolate the variable, and then we're going to go ahead and graph the possible solutions on a number line together. Alright, let's get started. For number 1, we have x plus 9 is less than 4. So here is our original inequality, and what we're going to do here is isolate x by going ahead and taking away 9 from both sides of this inequality. If we go ahead and take away 9 from both sides, we're going to get x plus 0, or just x, is less than, and 4 minus 9 is going to be negative 5. So as long as x is less than negative 5 or smaller than negative 5, this would create a true statement. Okay, so we've solved our inequality here, so we know that x has to be less than negative 5. How are we going to go ahead and show that on a number line? Let's go ahead and plot this number down as negative 5. Let's go ahead and put that in the middle here. And generally, we put two numbers less than negative 5 and two numbers greater than it. Feel free to jump by whatever numbers you would like to. I'm going to jump by 2's here. So these are two numbers that are smaller, and here are two numbers that are greater or bigger. Now we know x has to be less than negative 5. That's where we're going to go ahead and put an open circle on negative 5 because x is not allowed to equal negative 5. You would fill it in if it was allowed to. And x has to be less than negative 5. So that's going to be all the values to the left here on the number line. All right, let's try another one together. In number 2, we have x minus 14 is greater than negative 3. All right, so to isolate x here, we're going to go ahead and use the addition property of inequality. Let's go ahead and add 14 to both sides of this inequality. If we go ahead and do that, we're going to get x alone on the left side, and it's going to be greater than negative 3 plus 14, which is going to be equal to 11. So as long as x is greater than 11, we would have a true statement here. So that's going to be our solution. Now, if we want to graph these possible solutions, let's go ahead and put 11 in the middle here. I'm going to jump by, let's go jump by 5s here. Maybe that'd be 16, that'd be 21. And if we go down by 5, that would be 6, and down by 5, that would be 1. Now, x has to be greater than 11. It can't be equal to 11. So again, let's put another open circle here. And which way our number is greater than 11, that's going to be to the right. So anything to the right of 11 or greater than 11 would make this inequality true. For number 3, we have 4x is less than negative 28. To solve this inequality, keep in mind that we want the coefficient for x to be equal to 1. Right now it's equal to 4, so the inverse of multiplying x by 4 is going to be dividing it by 4 here. So 4 divided by 4 on the left side, or 4x divided by 4, is going to be 1x, which we can just write x. That's going to be less than negative 28 divided by 4. Well, 28 divided by 4 is 7, so the opposite of that is going to be negative 7. So as long as x is going to be smaller than negative 7 or less than negative 7, this would be true. All right, just like before, let's go ahead and put our negative 7 in the middle here, our solution. I'm going to jump by 3's here. So 3 more would be negative 4, 3 more would be negative 1, 3 less would be negative 10, and 3 less would be negative 13. Now, x has to be less than negative 7. It can't be equal to it. So just like the last few examples, let's put an open circle. And if x has to be less than negative 7, the numbers here that are less than negative 7 are numbers like negative 10 and negative 13, or to the left of it on the number line. Let's check out number 4. For number 4, we have negative 3x is less than or equal to 27. So there's a couple different things about this problem compared to the last few examples. One is going to be the fact that we have this line underneath the inequality that means less than or equal to. That's going to change our graphing a little bit. And also keep in mind that we have a negative coefficient here in front of x. And when we're dealing with inequalities, when you multiply or divide by a negative value, you're going to actually flip the inequality symbol the other way. So just keep that in mind when you're looking at problems like this. Okay. So first things first, we want our coefficient for x to be positive 1, but right now it's negative 3. So the inverse here is going to be dividing by negative 3. So we're going to do that on both sides of the inequality. Now, negative 3x divided by negative 3 is going to be positive 1x, or just x. Now, because we divided both sides by a negative number, instead of saying less than or equal to here, we're going to say greater than or equal to. And on the right side, 27 divided by 3 is 9. So 27 divided by the opposite of 3 must be the opposite of 9, or negative 9. So in this particular problem, as long as x is greater than or equal to negative 9, this would make the inequality true. Now for the graph, let's go ahead and put -9 in the middle here. I'm going to jump by ones here, so let's go -8 and -7. Those are getting bigger, and going by ones, -10, -11, those are getting smaller. Now, where we're going to put that circle, we're going to put it right on this -9, and keep in mind that x is allowed to equal -9 or anything greater, and anything greater would be numbers to the right on the number line like this. For a fifth example, we have x plus 15 is greater than or equal to -29. Now to solve this inequality, to get x alone, let's go ahead and do the inverse of adding 15, which is going to be subtracting 15. If we go ahead and subtract 15 from both sides, we're going to get x plus 0, or just x, is greater than or equal to. And on the right side, we have -29 minus 15, which is the same thing as -29 plus -15. So a negative plus a negative is just more negative. That's going to be -44. This would be our solution. All right, so if we're going to go ahead and throw this on a graph to see what this looks like, -44 is going to go in the middle here. I'm going to jump by 4s just because I feel like it. Feel free to jump by another number. So -40, -36, and if we go 4 smaller, it's -48, and 4 smaller would be -52. All right, now let's go ahead and put what kind of circle on that -44. Well, x is allowed to equal -44, so let's fill it in to show that. And x has to be greater than or equal to -44, so let's go ahead and draw an arrow to the right here. All right, cool. Here is a sixth example. In this one, we have -8x is less than -72. All right, so this is one of those problems where you have to be careful again. Notice our coefficient for x is a negative value, -8. So remember, whenever we have to multiply or divide by a negative value, we have to flip the inequality symbol, okay? So in this case, to get a +1 for the coefficient of x, let's go ahead and divide both sides by -8. So on the left side, -8x divided by -8 is just going to be +1x, so that's just going to be x. Now what's going to happen to this less than symbol? It's going to flip the other way. It's going to turn into a greater than symbol. And then what is 72 divided by 8 is 9, but it's the opposite of 72 divided by the opposite of 8. So the opposite of 9 is just 9. All right, so this would be our solution. So that we can visually see our solutions, let's go ahead and put 9 in the middle of our number line. Let's just go up by 3s here. I'm going to put a 12 and a 15. Going down by 3s, I'm going to put a 6 and a 3. Now, x has to be greater than 9. It's not allowed to equal 9, so let's put an open circle and let's draw an arrow to the right. Let's check out number 7. For number 7, we have 3/4 x, or 3/4 times x, is less than or equal to -18. All right, so how are we going to isolate x here? Well, notice how the coefficient for x is 3/4. If we want to get that coefficient to be +1, we could do one of two things. We can go ahead and divide both sides by 3/4, or we can multiply both sides by 4/3. Now, I'm going to choose to use the multiplicative inverse here, which is multiplying both sides by 4/3. And so let's go ahead and write that on both sides, right? Keep in mind, dividing by 3/4 would be the same thing as multiplying by 4/3. So if you go ahead and multiply these two fractions, because they're reciprocals, you're just going to get 1. So I'm just going to go ahead and write 1x, or just x, and that's going to be less than or equal to. And on the right side of this equation, let's go ahead and just show what that's going to be. So we're going to have to multiply these two fractions. I'm going to go ahead and show that on the side. -18 is just -18 over 1. 4/3, I'm just going to write as 4 over 3. We can go ahead and cross cancel the 3 and 18. Their GCF is 3, so you can divide them both by 3 to get 1 and to get this -6 on top. So if we multiply -6 times 4, that's going to be -24, and it's going to be -24 over 1, which is still -24. So x would be less than or equal to -24 here. This right here would be our solution. Throwing this on a graph, this -24 would go right in the middle. I'm going to jump by 2s here, so 2 bigger would be -22, then -20. 2 smaller would be -26, then -28. Now, what kind of circle are we going to put here? Well, let's go ahead and put a closed circle since we are including -24 as a possible solution. X has to be less than or equal to this, so the numbers that are less than -24 are to the left of it on the number line. Let's check out number 8. In number 8, we have x divided by -4 is greater than -5. Alrighty, so how are we going to get x alone here? Well, right now on the left side, x is dividing by -4. So what's the inverse of dividing by -4? It's going to be multiplying by -4. So let's go ahead and multiply the left side by -4. Let's multiply the right side also by this -4. All right. Now on the left side of the equation, these -4 over -4 is just going to be equal to 1 because anything divided by itself is equal to 1. So we're just going to get 1x or just x. Because we are multiplying both sides by a negative, keep in mind that we're going to have to flip this inequality from a greater than sign to a less than sign. All right. Remember, if you multiply or divide by a negative number when you're dealing with inequalities, you're going to have to flip the inequality. On the right side, we have a -5 times -4. A negative times a negative is a positive because the opposite of the opposite is just the original. So we're going to have x is less than 20. So this right here would be our solution. Now going ahead and graphing our solution, we're going to put 20 in the middle here. I'm going to jump by 5s, put 25 and 30, then go down by 5s, I'll put 15 and 10. Now I'm going to go ahead and put an open circle on 20 because x is not allowed to equal 20, it has to be less than it, and the numbers that are less than it on the number line are going to be to the left, so anything in this direction. In this next example, we have 5/4 times x is less than -45. Alrighty, so we've seen a problem like this in the past. What we could do on both sides, because 5/4 is multiplying by this x, is we could divide both sides by 5/4, or you can know that dividing by 5/4 is the same thing as multiplying by 4/5. So I'm going to go straight to that and use that, which is called the multiplicative inverse. So I'm just going to go ahead and multiply both sides by 4/5. On the left side of the equation, notice that the 4/5 times 5/4 will just equal 1. So we just have 1x on the left side of the equation, or just x. And on the right side of the equation, we have -45 multiplied by this 4/5. So I'm going to go ahead and write that on the side here. So -45 is -45 over 1. And 4/5 is just going to stay the same here. Now when you're multiplying fractions, we should try to cross cancel. So 5 and 45 both can be divided by 5, that's their GCF. 5 divided by 5 is 1, and -45 divided by 5 is going to be -9. So we just have -9 times 4, which is going to be -36 over 1, which is -36. So x would be less than -36 to make this inequality true. So that would be our solution. Now to graph this, let's go ahead and put -36 in the middle here. Let's just jump by 2's maybe, so -34, -32, and going by 2's in the smaller direction, -38 and -40. Now, x has to be less than -36, it can't be equal to it, so let's put an open circle, and the numbers that are smaller than -36 are to the left here. Let's try another one. In number 10, we have x divided by 8 is greater than or equal to -7. All right, so right now x is dividing by 8. So what's the inverse of dividing by 8? I think that's going to be multiplying by 8. So on the left side here, let's go ahead and multiply by 8 over 1. And on the right side, I'm just going to multiply it by 8. So that's the same thing on both sides. Now, on the left side here, if we multiply, we're going to have 8 over 8, which can cross cancel to just equal 1. And so we're just going to have x on the left side. That's going to be greater than or equal to -7 times 8. 7 times 8 is 56, so -7 times 8 is going to be -56. So this would be our solution. On a number line, let's go ahead and put -56 in the middle. Let's jump by 6's here, so -50, then -44. Going 6 smaller would be -62, then -68. Okay, let's go ahead and put what kind of circle on -56. I think it's going to be filled in, right? Has to be greater than or equal to -56, so we can fill it in because it include it, and then draw an arrow to the right here. For number 11, we have -3/8 times x is greater than -15. All right, so we'd like the x to be alone, but we have this negative coefficient in front of it. To get the coefficient for x to be +1, again, just like in earlier problems, you could divide both sides by -3/8, or what we can do is multiply both sides by the multiplicative inverse, or the reciprocal of that coefficient, which is going to be -8/3. Now, if we do it to the left side, let's go ahead and do it on the right side, just so we can stay nice and consistent here. So if we multiply this -8/3 times this -3/8, the two negatives cancel out to make a positive, and then the 8's and the 3's will cross cancel. We're just going to be left with 1x, or just x. Now, another thing to think about here is we just multiplied both sides by a negative value. And when we do that with inequalities, we're going to have to flip this greater than sign to a less than sign. So let's go ahead and put a less than sign. And then on the right side, let's go ahead and just show this on the side a little bit. We do have a negative times a negative, so that will get us a positive, but let's go ahead and just show the details here. So negative 15 is negative 15 over 1. Negative 8/3, doesn't matter where you put the negative, I'm going to put it on top here. Top or bottom is fine. If we can cross cancel, let's do so. 3 and negative 15 can both divide by 3. 3 divided by 3 is 1, and negative 15 divided by 3 is negative 5. At this point, we have negative 5 times negative 8, which is going to be a positive 40 over 1, which is positive 40. So as long as x is less than 40, our original inequality would be true. So this right here would be our solution. All right, for the graph here, let's put 40 in the middle. I'm going to jump by 5s. I'm going to go ahead and add 5 each time, then take away 5, take away 5. There's going to be our numbers, and x has to be less than 40, so it can't be equal to 40, so keep that an open circle. And then let's go ahead and draw an arrow to the left here. Here's one final example. In number 12, we have 9/4 multiplied by x is less than or equal to negative 36. All right, so just like in the last example, we would like the coefficient for x to be equal to 1. So how do we turn this 9/4 into 1? Well, because 9/4 is multiplying by x, let's go ahead and multiply this left side by the reciprocal of 9/4, which is 4/9. If we do that to the left side, let's go ahead and do that to the right side as well, just so we keep everything nice and balanced. On the left side here, the 9s will make 1 and the 4s will make 1 as well. So again, reciprocals always multiply to get 1, so we have 1x. Let's not flip the inequality here because we're multiplying both sides by a positive number, not a negative number. So just be careful about that. And on the right side here, let's go ahead and multiply this negative 36 by this 4/9. So let's go ahead and write that out. Negative 36 over 1 multiplied by 4/9. Let's see, we can cross cancel here. 9 and negative 36, you can divide those both by 9. 9 divided by 9 is 1, and negative 36 divided by 9 is negative 4. So negative 4 times the 4 is going to be negative 16 over 1, or just negative 16. So that would be the right side of this inequality. So we can say that x has to be less than or equal to negative 16. Alrighty, so for a quick graph, let's go ahead and put negative 16 in the middle. I'm going to jump by 8s here, so we'll have negative 8 and 0. And going smaller by 8, that's negative 24. And smaller by 8, that would be negative 32. So what could x be? Well, x is allowed to be less than or equal to negative 16. So let's go ahead and put a closed circle on this negative 16 because it's allowed to be negative 16. And anything that's smaller than negative 16 would make this inequality true. All right, so there you have 12 different practice problems on solving some one-step inequalities. Keep in mind that whenever you have to multiply or divide both sides by a negative number, that you actually have to flip the symbol for the inequality just because you're reversing the number line in essence. So just try to remember that in the future. Hopefully the graphs made sense too. If you have a less than or greater than symbol, keep an open circle. If it's less than or equal to or greater than or equal to, make sure you fill in that bubble or fill in that circle to show that it's allowed to equal that number as well. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep with the great work that you're already doing.